So we're going to continue our work with rational numbers, which you know just means fractions. We are going to review solving equations, and we're going to revisit solving inequalities. Now, inequalities are math statements we have not seen since November, so I want to review with you. I chose those as the vocabulary words for this lesson. First, we have an inequality. An inequality is a statement formed by placing an inequality symbol between two expressions. So the difference between an inequality and an equation is that instead of using an equal sign, we use either less than, greater than, less than or equal to, or greater than or equal to. And with equations, while there is a single answer, inequalities have a whole range of answers that make the statement true, which leads us to our second vocabulary term, the solution of an inequality, and it's the set of all the numbers that make the inequality statements true. Now, before we go on to our first example, which will be solving an equation using fractions, there is a new method that I want to show you, and there's a list of steps that you'll need to copy before we move on to the example. So these steps are for solving equations and inequalities by clearing the fractions. So the first thing that you need to do is find the LCD, which you know means the least common denominator. Then, rather than make equivalent fractions, which is what we did in the last lesson, what we're going to do is multiply every single term of the equation or the inequality by that least common denominator. Then we will cross-simplify, which I insist that you do. Then the steps that follow are the same steps that you know for solving equations and inequalities already. First, we will negate the constant, and then divide both sides by the coefficient to isolate the variable. And so in our first example, we are going to follow these steps to solve. And it's important that you recognize that when it says solve by clearing the fractions, you absolutely must follow this method. So our original equation is this. A negative 2/9 equals 3/4 x minus 1/6. Now, if you look to your steps that you just copied, the first step is to find the LCD, which for 9, 4, and 6 is 36. And then the second step says multiply every term by the LCD. And you remember what we do is, because we are working with fractions, we take the least common denominator and put it in fraction form. So first, what we'll do is we'll multiply the negative 2/9 by 36. Then we have 36 times the 3/4 x, and then 36 times the negative 1/6. And the next step is to cross-simplify. Here, when we cross-simplify, we know that the 9 will go into itself once, and 9 goes into 36 4 times. Here, 4 goes into itself once, and it goes into 36 9 times. And 6 goes into itself once, and it goes into 36 6 times. And the whole point of clearing the fractions is that we're dealing only with integers and not any rational numbers. So now what we have is 4 times a negative 2, which is negative 8. It's actually negative 8 over 1, but I'm just going to go ahead and skip that step and go right to the simplifying. Next, we have 9 times 3x over 1, which gives us 27x. And then 6 times 1, negative 6 times 1, which is 6. And now what we have is just a two-step equation. The first thing that we need to do is put a positive 6 on both sides. Let me switch colors so it's easier to see. So we have a negative 8 and a positive 6, which gives us 27x minus 6 plus 6. A negative 8 and a positive 6 together make negative 2. This leaves us with 27x, because the negative 6 and the positive 6 together make a 0. And then when you divide both sides by the coefficient 27, you get a final answer of x equaling a negative 2 over 27. And that's our final answer. And I just want you to understand that though we used an equation in this example, you would follow the same steps for solving inequalities that have rational numbers. Now the next thing, in our next example, what we have are decimals, and we haven't really used decimals in a long time, but again, there are steps that you need to follow because while we cleared the fractions in example 1, we're going to clear the decimals in example 2 because what we want, again, is to deal with just integers. We don't want any decimals. So the steps to solving equations and inequalities. First, you have to identify the term that has the most decimal places and then count those decimal places. And I know this will be confusing, but as we work through the example on the next board, this will make a lot more sense. Next, you're going to multiply every term by the power of 10 that will produce whole numbers. So for instance, if the greatest number of decimal places in your equation or in your inequality is 2, then you would multiply every term by 100. The 2 decimal places, you would choose the power of 10 that has the 2 zeros at the end. And if we were to take that a step further, if the greatest number of decimal places was 3, then you would multiply every term by 1,000, the power of 10 that has 3 zeros. And then after that, you would have just whole numbers. You would simplify, you would negate the constant, divide by the coefficient to isolate the variable. Okay, here we have solved the inequality by clearing the decimals. When you have this in your directions, you absolutely must follow this method. So here we have our original inequality. 6.6x plus 10.56 is less than or equal to 26.4. Now our first step is to identify how many decimal places we have. In the 6.6x we have only 1. In the 10.56 we have 2. And in the 26.4 we have only 1. Now since 2 is the greatest of the 3 terms, we are going to multiply every term by 100, which you can see on our next line, I set up. Now, if you remember the rule for multiplying decimals by powers of 10, what you would do is count the number of zeros, 1, 2, and then you would take the decimal point and move it 2 places to the right. So, just to reiterate, for however many zeros you have in your power of 10, that's the number of decimal places you move the decimal to the right. And when we move this decimal place, two places, 1, 2, what we would do is fill in the empty space with a 0, and we have 660x. And then when we have our 10.56 multiplied by 100, we take our decimal point and move it twice, 1, 2, which gives us 1056. And when we take our 26.4 and move the decimal 1, 2 places, and we fill in a 0, we have 2,640. So now we have a much, what I like to say, a friendlier inequality that we're solving. We have 660x plus 1,056 is less than or equal to 2,640. And following the steps that you just wrote, what we need to do now is negate the constant. Our constant here is a positive 1,056, so we apply a negative 1,056 to both sides of the inequality. When we do and we simplify, what we have left is 660x is less than or equal to 1,584. And then when you simplify, when you divide by the coefficient 660, you get x is less than or equal to 2 2/5. And we have one more example, a word problem. Okay, here it goes. The store where you are shopping is having a sale. All jeans are 2/3 off their original price. You're going to buy one pair of jeans and a t-shirt. Your budget is $55. The shirt that you want costs $19. What is the highest original price of jeans that you can afford? Now I know that when we look at word problems, typically our first response or first reaction is, wow, there's a lot of words there. I'm never going to be able to solve this. And that's normal, but what we need to do is work through it and organize ourselves. And so, you should model what I do. Take out all the information that you need and leave everything else separate. What do we know? We know that we have a budget of $55, which means that that is the most that we can spend. We know that the shirt that we want is $19, and we know that jeans are 2/3 off. So how do we take this information that we culled from the very long word problem and work it into the inequality that we need to solve the problem? Well, here's where we start. We take our total, and I like to put it over here on the right. That's our budget. And we know that this is the absolute most that we can spend. So anything that comes before the 55 has to be less than or equal to it. So that's how we can know. If the number is the most that we can spend, then everything that precedes it has to be less than or equal to it. What else do we know? We know that our shirt costs $19. That'll be our constant. And we know that we can buy a pair of jeans, and we're going to take off 2/3 of the price. When we hear that something is 2/3 of something, that of indicates to us that the operation is to multiply, and so that's why I have 2/3 times x. Just want to remind us that this is less than or equal to. Now everything here is actually nothing new at all. What we're going to do, so just remind you, just because we have a fraction here, it doesn't mean we're going to clear the fractions. This is really pretty much like a problem that we had in the lesson before where we used multiplicative inverse. So the first thing we're going to do is negate the constant. We'll do that by putting a -19 on both sides. When we do, we end up with 2/3 x is less than or equal to 55 minus 19 is 36. Now, as I referenced before, we're going to use the multiplicative inverse to solve this. That means we're going to multiply both sides by 3/2. The 36/1. Then we'll cross simplify. 2 goes into itself once. 2 goes into 36 18 times, giving us, and we'll write the answer up here just so it's easier to say. This leaves us with, after we do our cross simplifying, x is less than or equal to $54. So if you pick up a pair of jeans that originally cost $54, they'll only cost you $18. Not bad.